Okay, so let's start. My name is Shutanu Sadhukan. I am a PhD student at IIT Bombay. I am your facilitator for the weekly interactive sessions of NPTEL course code C86 uh, of the course name Water Economics and Governance. So, where are we? We are at the third week. It is 15th August. So, happy Independence Day, everyone. Actually, today is a public holiday. I didn't expect much people to join, but we have to remember that our healthcare professionals are still working. Our whatever your soldiers are still there at the borders, and also our mother is also working, or people who are staying in mess, staying in hostels. The mess workers also cooking food for us. So that might be a big motivation for people who will be joining online. But anyways, later people can watch the recording also, as it will be uploaded, just like other days. So welcome to the third week. Today we'll be discussing mostly MCQs because most of your assignments are MCQs only. We'll also solve some problems. So let's start with some MCQs. So the first MCQ for you. You can either unmute yourself and talk, or you may type your answer in the chat box. And if you have any doubt regarding any concept or any of the previous sessions those are conducted, you can ask questions. I may clarify in this session, or later the clarification can be sent in mails also, or it can be discussed in later classes also. So let's start. The first MCQ is as follows. Uh, Renewable resources must be used no faster than the rate at which they regenerate is a statement under option A, the Dublin Statement on Water Sustainability, option B, OECD policy objectives, option C, the Dali rules for sustainability, and option D is none of the above. So you can type your messages in the chat box, you can type the answer, or you may unmute and talk. Okay, so Dhanesh is telling option C, Dali rules for sustainability. Jim is also telling option C. Okay, so we'll see the answer. So renewable sources must be used no faster than the rate at which they regenerate is a statement under, as you correctly said, the Dali rules for sustainability. So option C is correct. Okay. Now let's move forward. I wanted to let you know a bit about the OECD, which is Organization for Economic Cooperation and Development. So, what is it? It is actually a body which has the objectives which are fostering economic development, prosperity, equality, opportunity, and well being for all, and fighting poverty through the promotion of economic stability and cooperation. It's just like an intergovernmental body, just like IPCC, which is Intergovernmental Panel on Climate Change. This is also OECD, also an international body. So it has 38 member countries altogether, India is a participating partner in policy discussions, and India takes part in regular OECD surveys, but as of today, it is not a member country among the 38 member countries. Why? Because this body OECD actually publishes an yearly report in which it has developed a ranking systems based on the presence of market restrictions in a country. So this ranking index is called STR, or Services Trade Restrictiveness Index, STRI. Based on this index, basically 50 countries last year participated, and they were ranked like that way. Japan was the first, second one was UK, third place was for Netherlands, and fourth was Czech Republic, like that way, Czech Republic. But India took place 47th rank after Israel and before Russia, Thailand. So the thing is that the market restrictions, I mean, one cannot judge it is to be a good or bad. It depends on the socio-political scenario of a particular country, whether it is necessary for that country or not. But as India is moving towards a open economy, and India is actually it is a highly developing stage now, so we can assume that in the near future it will be active member of the OECD, that is Organization for Economic Cooperation and Development. So actually, in your options, there was DALI, there was OECD, and there was also the Dublin statement. So further questions will be coming on that. So I wanted to let you know a bit about OECD. So going forward, your second MCQ question is, which of the following pairs is incorrect? So option A is Ganga. There are certain states names with the river, that is Uttarakhand, Uttar Pradesh, and Bihar. Option B is Krishna. The name of these states are associated with this river are Kerala, Maharashtra, and Karnataka. Option C is Kaveri. The name of the associated states are Tamil Nadu, Karnataka, and Kerala. And option D is Godavari. The name of the associated states are Karnataka, Andhra Pradesh, and Chhattisgarh. Actually, you can type your answer in the chat box. What it is here pointing towards, actually it is meaning that these rivers are actually flowing through these states. So whether these states associated with the river is relevant for the flowing of the river. So whether the river has been flown through that state or not. So if that river has not flown through that state, then the associated pair will be incorrect. So which one of the these four options are incorrect? That is, the question is actually asking that. So let's see uh, how the answers are given. Okay, Ojim is telling that Kerala. So Kerala is in option B. Okay, and Karnataka too. Yeah, flows through Maharashtra and AP. Okay, okay, okay. So we'll see the answer, as not much participants are there today. So we'll quickly go through. So we don't wait much. So I believe you have given the correct answer. Yes, the Krishna River actually originates in the Western Ghats or Paschim Ghat near Mahabaleshwar in the state of Maharashtra and flows through Karnataka, Telangana, and Andhra Pradesh. So Kerala is not a relevant state here. So option B is the correct option, as you correctly said. I remember Ojim attended last class. So there you actually raised question, not last before the last class. So actually you asked questions regarding certain problems, 12, 15 and maybe 13. So similar problems was discussed in the last class actually. If you have seen the recorded lecture, so then I think it has helped you in solving those assignments. So in this class also, this type of numerical problems which will be relevant to your assignments will be discussed. And also I believe, yeah, okay, okay. So welcome, Sanjoy. Uh, we'll continue. So yes, option B is the correct option. Okay. So next MCQ is, water is allocated to the most beneficial uses for meeting which of the following? Option A is environmental sustainability. Option B is economic efficiency. Option C is social corners, and option D is resource conservation. So we'll wait for 2 minutes for the answers in the chat box. Okay, Dhanesh is telling option A, environmental sustainability. Okay, Ojim is also telling option A. Okay, we'll see. So economic efficiency of sustainable water management is concerned with allocation efficiency of water resources involving no or minimum wastage, along with regulations for ensuring optimum resource allocations among stakeholders. So option B, economic efficiency, is the correct answer. Okay, so there is no problem because these sessions will not be evaluated. So I encourage people to give the answer. So there is no problem if the answer is wrong. This is just a practice sessions. So this is not going to be evaluated. Uh, this is for doubt clearing and learning only. So please don't be shy away. Please give the answers. It is okay. So the more you are answering, the more the concepts will get clear. Okay. So we'll move on to the next section. The next MCQ is, the ephemeral rivers are short-lived rivers which originate due to heavy rainfall and are marked as which one of the following? Option A is the coastal rivers. Option B is the rivers of Deccan Plateau. Option C is the rivers of inland drainage basin, and option D is the Himalayan rivers. So these rivers are short-lived and they originate due to heavy rainfall. The other times, mostly the river basins remain dry or the water level remains very low. These are not regular rivers. rivers. If you focus on the question, the answer is, I think, guessing the answer will be easier. Or if you have attended the sessions, which I highly encourage, then you will be able to answer. Okay, so Ajim and Donesh is telling option C, the rivers of inland drainage basin. I also encourage Sanjay to answer. Okay, so yes, this is a correct answer, I guess. We'll see. The ephemeral rivers are short-lived rivers which originate due to heavy rainfall and drain inland. Luni in Rajasthan is an example of such river. And as you correctly said, the option is C, the rivers of inland drainage basin. Because here what happens that uh, due to over raining, not over raining, actually due to what is called runoff also, the extra water that actually uh, flows through these kinds of rivers, and whenever the rainy season is over, whenever the dry season comes, then the rivers, there is not much flow in these kinds of rivers. So option C is correct. Both of you have given the correct answer. Okay, so we'll continue to our next MCQ. Sustainable management of water resources involve option A, free water services for basic human needs. Option B, unlimited use of water for activities beneficial to human. Option C, meeting current water needs without compromising the opportunities of future generations. And option D is singular decision making. The name sustainable actually means the answer. So if you know what sustainable management of water resources mean, then you will be able to answer, I think. You have heard the lectures provided by Dr. Tiwari in your online recorded lectures. If you have watched, then the answer is quite simple. Okay. Okay, so Ajim is telling option A, free water services for basic human needs. Donesh is telling yes, option C. So meeting current water needs without compromising the opportunities of future generations. Okay. Sanjay? Sanjay, you are not answering. Why? You can, if you are unable to type, you can unmute and say your answer. Okay. So what? So the term sustainable means something which current generations are using, but the resources are not over exploited. So for future generations, enough usable resources are there. So current usage of the resources does not lessens the opportunity of resource utilization by the future generation. So I guess option C will be correct in this case. Let's see. So yes, current water needs without compromising the future ability of resources to meet the need. So option C is correct. Okay. Now next MCQ is, which one of the following water body contributes maximum to the atmospheric moisture? Water body. Option A is river. Option B is ocean, option C is lake, and option D is pond. You can type your options in the chat box. Option B, ocean, Ojim is telling. Sanjay, are you there? Jonas has both Ojim and Jonas has told that option B is the option, correct option. I think it is the correct answer only. So yes, Sanjay has also told option B. So evaporation from the ocean contributes 90% of atmospheric moisture. Actually, the more the surface area, the more the amount of evaporation. So if we compare within these water bodies, ocean has got the largest surface area. So the more amount of water vapor is possible from to go from ocean into the atmosphere as compared to the other water bodies like river, lakes and ponds. So that's why ocean has is the highest contributor of the atmospheric moisture, almost 90%. So option B is correct, as you all have correctly answered. Okay. So next MCQ. Under the, as I told that previously there was Dali statement, there was Dublin statement, and there was your OECD. So OECD we have talked about. Dali statement as also we have also talked about. Now, under the action agenda of the Dublin statement, the better access to a potable water supply and sanitation services to rural population was regarded as which one of the following? Option A is an immense task but not an impossible one. Option B is a close to impossible task. Option C is an easy task if society demands for it. And option D is a very easy task if state has willingness. Somebody, as I remember, asked one question in the discussion forum that if water responsible sharing of resources is a just a national or intergovernmental level things, or within state also it is applicable. So I believe that see, responsible use of water or responsible sharing of water resources is called as stewardship. So the water stewardship is for any sensible, honest, and transparent civilized country. It is applicable within the states also. That it is not so that for only uh, at the national level or international level or intergovernmental level it will be applicable. So if the states, for example, in terms of pollution also, there exists state pollution control boards, there exists just like the national pollution control board or international bodies. So similarly in terms of water usage also, maybe in some cases or in some African or in other not much developed countries, they are still in the developing phase, but the planning is there. So it is water stewardship, that is the responsible use of water, responsible use and responsible sharing of water resources is applicable at the national level, at the state level, and at the international level. All the three levels it is applicable. So, as per the Dublin statement, we'll see what you are answering. Okay, Ojim is giving the answer as A or D. Dhanesh is telling option A, that is an immense task but not an impossible one. Okay, Sanjay. Yes. So Ajim has told the last question, he has told it correctly, that as it has large surface area and evaporation it is more as compared to others. Yes, definitely that is the reason for which the ocean contributes more in the atmospheric moisture. If sometimes if you see the rate equation of evaporation, you will see that the area is at the denominator. So if it goes at the right hand side, it goes to the it gets multiplied with the rate equation. So the more the surface area, the more the amount of water goes into the air. So if you have done any problem regarding evaporation in your BTech or MTech level, then you will see that. Okay, so we'll go forward with the answers. So the rural population must also have better access to a potable water supply, that means drinking water supply, and to sanitation services. It's an immense task, but not an impossible one, provided appropriate policies and programs are adopted at all levels. That is just like water stewardship I told, at the local, national, and international, all the three levels. So the option is A is the correct answer. An immense task, but not an impossible one. Okay. So the next MCQ is, most of the rainfall in India is caused by which monsoon winds? Option A is southeast, option B is northwest, option C is southwest, and option D is northeast. The monsoon winds are basically the air which comes over the oceans carrying huge amount of uh, moistures with them. They gets collided with the mountainous range in various places of a country. Just like India, in the case of India, there are there are Western Ghats, there are Eastern Ghats, there are Himalayas. So at the bottom region of the mountainous ranges, they actually causes the rainfall. The uh, air those contains the moistures gets collided with the mountainous ranges, and actually they causes the rainfall. So in case of India, which monsoon winds causes highest rainfall? There is a question. Danesh and Ojim is telling us option C as the correct answer, southwest. So if you remember your childhood textbooks in geography, so it was told that northeast region of India observes the highest rainfalls. So in the northeast region, there are basically the Himalaya range. So if the moisture containing air goes there and causes the rainfall, then what should be the, from which direction the actually wind will be coming? So I guess the answer they have guessed it correctly. We'll see. Yes. So southwest monsoon winds are the rain-bearing seasonal winds that flow from the Arabian Sea towards Indian mainland in the southwest direction, and leads to most of the rainfall in the period between June to September. So option C, you have guessed it correct. Okay. We will now go to the next MCQ. Which of the following is included in the guiding principles of the Dublin Statement? One, water sustainability. As I told, that questions on Dublin Statement will be coming. Option A is water should always be sold as an economic good. Option B is water allocation should prioritize uses with the highest financial returns. Should prioritize actually. Printing mistake is here. Users should be the primary policymaker for sustainable management of water. Option D is women play a central part in the provision management and safeguarding of water. So, which one of the four statements was there in the Dublin Statement? Ojim is telling as option B, that is water allocation should prioritize the use with the highest financial returns. Danesh is telling as option D. So what does this statement basically mean? So option A and B basically means the same, because it is telling us you treat the water as a commercial good. Wherever you get the highest financial returns, there you sell or distribute the water. Or you design the water distribution system as per the commercial value, highest commercial value, or as per the profitability. The water distribution system must be designed. It is the first two statements are basically telling that. Third statement is telling users should be primary policy for sustainable management of water. That means whoever is using the water, they should make the policy how the water is to be managed, needs to be managed. Just as we discussed in the last class, that there are the water scarcity and there are the economic water scarcity. So the difference lies in the that is called the management or structure for the infrastructure for the distribution of the water. The difference actually lies in the infrastructures. There are people, there are sources of water. So how they are getting distributed. So if there is a high gap, and due to that gap water scarcity is created, that is called the economic water scarcity. So in this case, what will be the correct answer? Should the policy maker decide, should the users must be the primary policy maker uh, for utilizing the for the sustainable management of water, and the management is also sustainable management. That is whoever the current generation is using, so future generations should not be affected by the water usage of the current generation. So I don't think option C is also will be there, will be the answer. Okay, so let's see what is the correct answer, because if it is based on the users completely, then for the current generation the management of water may be good, but for future generations it will not be good, so sustainable management will not be there. Okay, so the third principle of the Dublin Statement on water sustainability states that women play a central part in the provision, management, and safeguarding of water. Other given statements are not fully correct, as matter must be regarded as economic good for competing services only, and users can be the primary policy maker, but must be engaged in policy making. Because if they become the primary policy maker, then the management will not sustainable. And also the other cases, just like water is a basic need of human kind. So without water one cannot live. And the that is called the how the water is supplied to different sections of the society doesn't vary much from country to country, because if the country is in a Gulf country, that is a different issue. But otherwise, the water must not be a commercial commodity, because it is a otherwise it will only the supply of water will only get restricted to the rich. The weaker section or the poor section of the society will not receive if it is uh, allocated purely on the basis of the financial returns. But additionally, it has been seen that women play central part in the provision, management, and safeguarding of water, because they were from the ancient time they were engaged in agriculture in India. And the sustainable management, how it is done, how the water is safeguarded, actually there in NPTEL also there is one course called in ancient Indian technology. So if someone has done this course, it is offered by IIT Kanpur, I guess. So then certain ancient Indian technologies are well explained in that course, that how the ancient India, how women played a good part there in the provision, management, and safeguarding of water. So the Dublin statement has also recognized their role in this case in the sustainable management of water. Okay, so option D is the correct answer. Okay, so we'll talk a bit about the Dublin statement. We have talked earlier about the OECD and the DALI. The Dublin statement, we will take a 10 minutes break. After that, we'll join in the same link and we'll talk a bit about the Dublin statement. Okay. So until now, if someone is having certain questions, they can unmute themselves and talk, or they can type in the chat box. I guess the questions which are being practiced, it are in line with your syllabus, or difficulty level. I think it is at par with whatever assignment is given. We'll join at 6:55 at the same link. I'll pause the recording. Welcome back. Uh, Wait for 2 seconds for um, Ajim to join. They will join in the meantime. Okay. We'll start with the Dublin statement. Okay. So, what is basically the Dublin statement? Dublin, as we know, it is the capital of Ireland. The Ireland, the total Ireland island actually basically divided within two parts. The top part is North Ireland and south part is the independent country. It is Ireland. The Northern Ireland is a part of the United Kingdom. Can you anybody say what is the Dublin is the capital of the Ireland? That is the southern part. But what is the small northern part is there? That is the part of the UK. What is the capital of the Northern Ireland? Can anybody say? Any one of you, Danesh or Sanjay? Google is always there, but you can, if you know, you can type. That is basically Belfast. It is not. It is not our concern. However, just for knowing. So the Dublin Statement on Water and Sustainable Development, also known as the Dublin Principles, was a meeting of experts on water-related problems that took place in January 31st, 1992 at the International Conference on Water and the Environment, which is in short called as ICWE in Dublin, that is capital of the independent country or the southern part of Ireland. And the conference was organized from the January 26th to January 31st of the 1992. So we saw four options. The Dublin statement also had four statements basically. So it is on water and sustainable developments, and the statement recognizes the increasing scarcity of water as a result of the different conflicting uses and overuses of water. The declaration sets out recommendations for action at local, national, and international, all three levels, to reduce the scarcity through the following four guiding principles. So, what are those? Number one is fresh water is a finite and vulnerable resource essential to sustain life, development, and the environment. Option two is guiding principle number two is water development and management should be based on a participatory approach involving users, planners, and policymakers at all levels. But none of them should be the primary policymaking body. They obviously the users, the planners, and political political bodies who are there for the policy making, they should take part in the development of the management guidelines, but they must not be any one of them must not be primary policy maker. Number three, as we saw in the option also in the previous MCQ, women play a central part in the provision, management, and safeguarding of water that they recognized in the Dublin Statement. And the fourth guiding principle is water has an economic value in all its competing uses and should be recognized as an economic good. So the thing is that water is free, but water is the treated water, because the water as per the guidelines, or as per the that is called the levels, where the potability criteria is met. That means the fluorine must be at under this ppm level, the chloride must be under this ppm level. So these guidelines are there by national bodies, also by WHO also. So if we want to make the water and supply at that level, then the naturally available water sometimes needs to be treated, and treatments need basically energy, manpower costs, and many other costs. So that water cannot be if it is I mean uh, limitlessly used by the people, or if it is used more than that is required, then there may be crisis or scarcity of water created in other parts, from where people are not uh, getting easy access to the water. So that's why the economic value of all its competing uses and competing uses must be recognized, and water also should be recognized as an economic good. So all of these four guiding principles was basically based on the increasing scarcity of water. And now the scarcity of water is not a just a abstract term to us. We also understand the scarcity of water in terms of we also quantitatively understand that what the scarcity means basically. So it is the 10 where the per capita availability of water is under 10 lakhs of liter per annum, then the international norms for global water distribution calls it to be water scarce. So the W statement actually considers this into the picture. Okay, so going forward, next MCQ is as follows: evapotranspiration value, that is evaporation plus transpiration from the vegetations, that is affected by A, air temperature, B, humidity, C, wind speed, and D, all of the above. Okay, so let's see what you are answering. Okay, so so most of you are telling that option D is the correct answer. I also think so. The principal weather parameters affecting evapotranspiration are radiation, air temperature, humidity, and wind. The thing is that all the times it is not so that the all of the parameters must be either positively or negatively impact. So some of them may positively impact, some of them may negatively impact the evapotranspiration value. So let's consider the evaporation. If the air temperature is high, then the moisture holding capacity of the air is high. If the humidity of the air is high, then the moisture holding capacity of the air is low. And the wind speed, if the wind speed is high, then the agitation in the air is high. So if we focus closely, we'll understand that higher moisture holding capacity of air means higher evaporation, and lower moisture holding capacity of the air means lower evaporation. So evaporation is directly affected by wind speed and air temperature, but it is not directly or maybe inversely affected by the if either humidity increases, then the evaporation decreases. So this air temperature and wind speed has positive impact on evaporation, but all of the parameters affects the evapotranspiration value. Okay, so all of the above, as you all have correctly answered, option D is the correct answer. Okay, so there are certain statements you have to identify which one of the following statements are correct, or all of them are correct, or maybe none of them are correct. Okay, so statement 1 goes as follows: the trade-off between policy objectives of sustainable water services are often forced due to conflicts in sustainable water management. Statement 2 is an example of trade-off between social concerns versus economic sustainability could be a decision on whether to prioritize water allocation for domestic uses or to high value uses like industrial processes. So trade-off actually represents an opposing relation. For example, in membrane science, trade-off means permeability and selectivity trade-off. The more the water passes through the membrane, the less it becomes selective towards different salts it is separating. The more it is efficient in separating different pollutants or salts present inside the water, the less flux it produces in membrane science. So the trade-off basically means opposing relationships. Here in statement 2, it is between social concerns versus economic stability, and in statement 1, it is policy objectives of sustainable water services. Okay, so let's see. Okay, so Danesh is telling that statement 2 is correct. Previous both of you have correct, given the answer correctly. Okay, for a minute. Okay, Ajim is telling both these statements are correct. I also think both these statements will be correct. Okay, let's see. Because okay, so prioritizing water allocation for domestic uses is a social concern, while prioritizing high value uses like industrial processes are in favor of economic sustainability. Yes, so both these statements are correct in this case. Okay, okay, so now we'll solve a numerical problem. A river identified to be used as a source for water supply to a city having daily water demand as 500 MLD. MLD means megaliters per day or million liters per day. Million or mega means 10 to the power 6. Has a minimum dry weather flow of 57.5 meter cube per second. The dry weather flow means the flow of the river at non-rainy seasons. In non-rainy seasons, when the flow is basically minimum throughout the year. The dry weather flow is given as 57.5 meter cube per second. A minimum of 50 meter cube per second flow should be maintained in the downstream of the river throughout the year as E flow. We will come into this later. What is E flow? And groundwater is maybe used for any additional water requirement if needed. Based on the information, answer the following questions. Option 1 is you have to calculate the permissible or maximum water withdrawal from the river in megaliters per day, that is same unit as given in the question, or million liters per day, that is 10 to the power 6. And option 2 is additional water required to be sourced from groundwater in megaliters per day. So here in the question it is told that if with the river you cannot cater the requirement or the daily water demand, then you can draw additional water from the ground. So here it is said that how much maximum water you can withdraw from the river, and if the maximum water withdrawn from the river unable to cater the demand, then how much additional you need to draw from the groundwater, both in MLD, that is megaliters per day, they are asking. Can use certain hints. I will wait for 5 minutes. So hint number 1 is 1 megaliter, as I told. It is mega or million, the same thing. It represents 1000 meter cube or 10 to the power 6 liters. Okay. So Donis is telling it will be 1.648 mld, and 2 will be so you keep in mind the units. So one is in meter cube per second, and the demand is given as mld. So all are not same units. And 2 you are telling it will be the additional water required. Okay, from the ground it will. Okay, we will wait for 2 more minutes and we will see later. So it needs basically calculator. You can, if you are using from laptop, you can use your laptop calculator also. And if you are having calculator, you can use that, maybe scientific or non-scientific, or you can use your mobile phone also. I don't think scientific calculation will be required here. Only basic calculations, but just understanding the concept is required. Sorry that we dragged you into studying in a public holiday, but things are like that. You are also PhD students like me. You can understand that things are not always same in all professions. Okay, so Ajim is telling us 500 mld only as the permissible water withdrawal from the river. Okay, and uh, groundwater is zero. Okay, okay, so you can mm, okay, we can start discussing the answer now. Okay, so hint number two actually I didn't get. The acceptable range of answer will be 600 to 700 mld because here the permissible maximum water withdrawal they are asking. Uh, as Ojim, I think you have calculated the thing, but the thing is that the permissible limit may be greater than the demand. So it is not like that if 500 mld is expressed as the uh, demand, so I have to tell it uh, like that way. So maybe 500 mld is the uh, amount that of water that is getting withdrawn from the river, but it is not the maximum. Okay, we'll see the calculations now.
Can I interrupt?
Yes, yes, yes.
Yeah, actually, you said it right. The demand is less and the withdrawal rate is much more than the demand.
Yeah. Yes, yes, yes. So I thought you calculated it right, but as you thought that 500 is less than that, you told the 500 to be the answer, right?
Yeah, yeah, actually, I
Okay,
didn't calculate the surplus.
okay, okay, okay. We'll see. Yes, I understood. Okay. And Donesh, I think you have missed out the units. Maybe you have calculated in the same units. That's why you are getting such values. I think if you look the units carefully, the conversion between liters and meter cube, 1 meter cube equals 1,000 liter, and those things, if you consider, I think you can calculate correctly. Okay, no issues with that. It is just a practice session. It will not be evaluated. Okay, so we'll see. First of all, we'll see the concept of the e-flow. What is basically e-flow? E-flow means ecological flow or environmental flow. With various terminologies, it is actually called as or defined as. So, what basically it means? There is a river, for example, from upstream to downstream, from hill or mountain to sea, it is flowing. And for example, in upstream, there is a um, plant or factory which is withdrawing water from the river. But there is no guarantee that in the downstreams there no will not be any people who will not be there to use the water. In downstream, there will be usage. There will be people. There will be farms who will depend on the water. So that's why the upstream people they cannot entirely use that water, which will create problem for the downstream people to utilize that water. So that's why a minimum water flow must be there in the river. The no one has right to use that water fully and make that dry for the downstream people. For example, in case of Ganga river, which flows through the India and also Bangladesh. So there are international norms. India cannot stop the use the water entirely and divert it to the Hooghly River and don't give the Padma of Bangladesh. Don't India cannot uh, I mean divert Bangladesh of water. So actually there are international norms that you can use this much of water only. So for example, also the Sangpo River, which is Brahmaputra in India. So it is flowing through China, that is Tibet, and India both. So Tibet or China cannot stop utilize the water fully with them, and cannot make the Brahmaputra dry for flow dry through India and Bangladesh. So that is the thing. So there must be a minimum flow through the river always. One cannot utilize the water fully. So that is called the environmental flow. Or also there are not only the people, but also there are organisms who are living in the water also, in the river water also. So their life is also dependent on the water. So that's why there must be minimum flow to maintain the flow of water in the river. So in technical terms, it is defined as a system to evaluate the quality, timing, and quantity of water flows for sustaining the well-being of humans and ecosystem throughout the length of the river. In a country like India, the idea of e-flows is highly relevant because India is a very big country, and also the civilization is dependent throughout the river. So it is in some small countries, for example, some plants is there, and downstream not or in the coastal areas not much people living. But India is a very highly populous country, so there throughout the length of the river people are living, ecology is dependent. So and India is a very rich country in terms of rivers and canal systems. So that's why the idea of e-flow is highly relevant to our to a country like India. So let's return to the problem. So what are the given data? The given data is daily water withdrawal needed is 500 mld or megaliters per day. That is the demand. And dry weather flow in river, that is the minimum per second flow through the river. In rainy seasons, it will obviously exceed this value. Since minimum of 50 meter cube per second flow to be maintained in the river as e-flow or environmental flow, the maximum water that could be withdrawn from the river is 57.5 minus 50 meter cube per second equals to 7.5 meter cube per second. One cannot determine this value on the basis of flow through the river in wet seasons, because minimum flow must be, we have to keep in mind, must be kept in mind while designing. Okay, so if meter cube per second is converted to megaliters per day, it becomes permissible withdrawal from river equals to 7.5 meter cube per second becomes 7.5 into 1000 liters per second, that is divided by 24 into 3600, this many liters per day. That means 648 into 10 to the power 6 liters per day equals to 648 megaliters per day. 10 to the power 6 means mega or billion. Okay, so as total requirement, that is 500 megaliters per day, is less than permissible withdrawal. Sorry, yes, it is true. So then additional, there is no requirement, so it will be 0. So actually whatever the required water demand is there, that is 500 megaliters per day, that is fully catered by the maximum permissibility is more than that. So that is fully catered by whatever water is available to be withdrawn from the river. So that's why the additional requirement for groundwater is 0 in this case. Okay, so I think it is clear to Danesh the calculations. If there is any uh, 1 point, sorry, extremely sorry. I actually misunderstood. I thought it to be 1.648. Okay, okay. So number one, it is 648 MLD you calculate. Okay, yes, yes, it is correct. Okay, okay. And number two is zero. Okay, I thought it was 2.0. Okay, yeah, yeah, yeah. Both answers are correct. Yes. Okay. So, okay. So let's move on to the next MCQ. Hope the previous problem is pretty much clear. Recognizing water as an economic good helps in what? Option A is reducing wasteful uses of water. Option B is ensuring economic sustainability. Option C is achieving efficient water uses. And option D is all of the above. So as we discussed earlier, so economic considering water as an economic good has its benefits as well as has its negative impacts. So the negatives are there that there may be uh, unequal distribution of water. It may be skewed towards the rich section of the society. And the positive impact, it is that one of the options you will probably you are seeing the positive impact as we discussed earlier. Okay, so we'll not spend much time in this. So recognizing water as an economic good will lead to adequate charges on water uses. Thus, it would help in reducing wasteful uses of water, just like in case of water metering, thereby achieving efficient water usage and ensuring economic sustainability. So, as it is correctly answered by, okay, both of you have told. No, okay. So, Ajim has told all of the above is the correct answer. Yes, too. So, we will move on to the next problem. So, here you have to match the following columns. In the left hand side columns, it is given as water services resiliency, water services efficiency, quality assurance in water services. And in the right hand column, it is given as water treatment for waterborne disease control, minimization of water related disaster risks, and water metering for water loss control. So you can just keep one side order same and tell me the other side order, or either you can say the LHS order or you can say RHS order, whichever is affordable to you. Resiliency basically means if the service is like this today, so tomorrow the parameters of the service must be constant. So not much fluctuation must be there. That means resilience. If for example the average is almost same, it is not highly fluctuating, it is not becoming highly efficient in one day and it is the next day it is falling down, the next day then again it is becoming highly efficient. So the efficiency is very much constant throughout the time. That means the resilience. Quality means for example, if uh, let's say potable water has got certain parameters, the fluoride or chloride concentration must be so and so, the pH must be near to 7. So these are all the quality parameters. Those are actually maintained in water services. And efficiency means the pipelines, the leakages must be less. Whatever is being pumped, that is being supplied to the end users, like that way. So let's see what you are answering. Okay. So okay, so both of you have told that the option will be 2, 3, and 1. Okay, I also think so. Let's see. So the water metering and water loss control leads to improving efficiency of water services, while water treatment for controlling water-borne diseases is for maintaining water quality. Because if the quality is not maintained, then only either microorganisms present in water or maybe the chemical parameters are not as per what it should be, then it can cause the waterborne diseases like diarrhea or maybe fluoride, chloride, or arsenic related diseases. And reliability and risk minimization highlight the resiliency of water services. Okay, so both of you have given the correct answer. Water services resiliency relates to the minimization of water related disaster risks. The water services efficiency relates to the water metering or water loss control. As I told, that whatever is being pumped, that is being distributed to the end users or customers, and quality relates to the disease control. Okay, so let's move on. Now there is another MCQ. Polluter pay principle versus affordable development is a trade-off between option A is ecological sustainability versus financial sustainability. Option B is ecological sustainability versus social concerns. Option C is financial sustainability versus economic sustainability. And option D is social concerns versus economic sustainability. Wait for 2 minutes. Okay. Financial versus economic. Ojin is telling. Ganesh is also telling financial versus economic. Polluter pay principle. Okay. Versus affordable development. For example, as we discussed in the first class, cloud seeding. So, with the help of cloud seeding, any in any that is called deserts, rain can be caused, but sometimes the cloud seeding may not be economical, depending on the financial condition of the government of that particular country. So that time it becomes non-affordable. But we have to first look into what is polluters pay principle to understand this question. What is it basically? It means that the polluter should bear the expenses of pollution causing activities as decided by the public authorities. For example, in case of carbon emission, there is a concept of carbon dating. It says the more you emit carbon, the more tree you have to plant. So sometimes what the Northern American companies do, they emit the carbon in whatever amount they want, and they plant equivalent amount of tree in the Southern American countries. So what I mean, in this way they trade the carbon in terms of tree plantation. They trade the carbon emission in terms of tree plantation. But the problem is with this type of thing is that the Southern American countries remains underdeveloped or undeveloped because uh, they are doing the tree plantation, but the industrial development is happening in the North America. So there is though from the environmental point of view it is just, from the social or social point of view, or the people, from the point of view of the people who are living there, it is unjust. So there is a social concern, as increase in energy price will be a greater economic burden for low income than for high income households, because the developing countries has already reached to a portion of higher income. So but low income countries uh, needs their development, development in a fast pace. The higher income countries has already developed in that high pace, and that time they polluted. But now if this principle is applied, then there is a social concern and there is a hindrance to the low income households, because there is an excess economic burden that is put on them. So that's why here option B is the correct, because it though ecological point of view or environmental point of view it is sustainable, but there is a social concern. So this thing, the polluters pay principle, for example, in case of carbon emission there is carbon dating, in case of water economics and governance, with respect to affordable development there is a social concern. So it is a trade-off between the ecological sustainability versus social concerns. Okay, so let's move on to the next question. Here we have to again match the following columns. There are two columns actually. In left hand side, uh, here certain uh, instructions are given, or uh, certain suggestions are given, that is encouraging water saving, prioritize allocation to uses with highest value, minimize the life cycle cost of water services. Mm, Manoj Awalgaonkar, can you please make your, okay, I can also mute it. Okay, okay. So hmm. So how do I do? Yes. So yeah, and in the right hand column there is financial sustainability, there is environmental, and there is economic sustainability. So which one is which directive is related to which sustainability you have to determine. I'll wait for 2 minutes for you to answer. Uh, Manoj, I think the recording will be given. It will be available in YouTube, so you can have a look at that, and also the
Yes,
audio
yes,
will
sir.
be uploaded. So no issues with that. Okay. Water Ojim is telling water saving is related with environmental sustainability. B with one, that means with financial, and the life cycle cost you are relating with C, that is economic sustainability. Okay. Mm, I think A is the, you have given the correct answer, because water saving is related to the environmental. There is no doubt with that. But the rest two, Okay, we'll see. So here I have to tell you one thing. That is, highest value doesn't relate to the highest commercial value. I mean, if rich is getting something and poor are not getting that thing, that is not basically the value that is meant here. Value in terms of also a human value, you can consider like that. A moral value, not only the economic. Yes, yes. I think so. It will be like that way, or whatever you tell. Second, okay, we'll see. Okay, and also the commercial value also. So it is related. Whatever, if certain things are rich people are getting certain things and poor are not getting, then sometimes it also backfires. So though in terms of financial aspects it is stable currently, in future it may not be stable. So even if you consider commercial values, so it will not be sustainable. So I think that will be the correct answer, or whatever you get the second time. So the minimizing life cycle costs of water services helps in cost saving. Thus, financial sustainability is related to the option B, I think. So prioritizing allocation to use it the highest value, and encouraging water saving will ensure less burden on environment, thereby helping in environmental sustainability. So it is definitely true. Option A with 3. And prioritizing allocation to uses with highest value promotes economic sustainability. Okay, so the water saving, encourage water saving is related to the environmental sustainability. It is true. And the prioritize allocation to uses with highest value, it is related to economic sustainability. That is given in option 3. And the financial sustainability, which is option 1, that is related with the minimize the life cycle cost of water services. Okay, so let's move on. Now we'll have a problem. It is as follows. An industrial outfall is releasing 4.32 megaliters per day effluent to a river having flow rate as 12 meter cube per second. The background BOD level in the river is 0, and BOD in the wastewater, actually, and the industry is putting that wastewater inside the river. So the wastewater's BOD is, as it is generated in the industry, it is 12,050 milligram per liter. The permissible BOD limit in the river water is 10 milligram per liter. Now we have to calculate the BOD of the river water at the discharge point, assuming instantaneous mixing at the discharge point. You have to the unit is in milligram per liter, so the same BOD limit you have to calculate. And secondly, you have to calculate the percentage BOD removal required for the industrial wastewater to ensure the BOD of the river water sustains within the permissible limit even at the discharge point. So actually, this is not a very easy problem, but uh, intensive calculation is not required. If you have understood the concept, then it is easy. So we will first discuss what BOD is. So can somebody, the audience, tell me whether okay? So okay, so yes, Ajim, go ahead. Are you able to unmute yourself? Yes.
Yeah. Uh, BOD is actually biochemical oxygen demand.
Hmm.
Actually, it is the demand of oxygen required for the biochemical actions that are taking place into the water by the biological actions,
Hmm.
which need to be maintained. That is the overall biological reaction, which should be less than 10 milligram per liter, as
In this
mentioned by
case.
the
Hmm.
central government.
Hmm.
It can range up to maximum 30 milligrams per liter for a few of the industries,
Hmm.
but higher BOD values may result into biological activities which might be harmful for the aquatic life.
Yes. Yes. So whatever Ojim has told, that is correct. So add on to that, we will understand the concept in a simpler manner for solving this problem. So technically, whatever you have said, that is correct. So the thing is that basically it is biochemical oxygen demand. Sometimes it is also called biological oxygen demand, but biochemical is the correct term. So there is the water, there is dissolved oxygen inside it. It is called DO, or dissolved oxygen. There are pollutants inside the water, and there are microorganisms like bacteria, etc. Bacteria, or microorganisms like microbes, sometimes they are called. So what they do? There are actually basically two types of these microorganisms. Some are aerobic, some are anaerobic. Aerobic means they can use those pollutants as their food, and they can grow. So once they use those pollutants as their food, they degrade those pollutants with in presence of oxygen or in absence of oxygen. So if they are using oxygen to degrade the pollutants, then they are aerobic. If they are not using the oxygen to degrade the pollutants, then those bacteria or microorganisms are anaerobic. So the biological oxygen demand basically, or sometimes COD is also used, that is called the chemical oxygen demand, but we will not discuss that here. In this case, both COD and BOD are basically an indirect measurement of the pollutants that is present inside the water. So higher the BOD, higher the pollutants present inside the water. Lower the BOD, lower the pollutants. So the thing is that there is one meter that is called DO meter, dissolved oxygen meter. So if DO in the water measures, see, certain milligram per liter is the DO of the water, and if after some times the DO reduces to some other level, then the difference within the DO is called the biological oxygen demand, because the reduction of the oxygen indicates the amount of oxygen utilized by the bioorganisms present inside the water to degrade the pollutants present inside the water. So basically, it is an indirect measurement. They utilized that oxygen to degrade the pollutants. So we actually measuring the dissolved oxygen content and how much it has reduced. So with the help of the reduction, we are indirectly determining how much pollutant was there inside the water. But definitely the pollutants must be biodegradable. The non-biodegradable polymers, or aerobically biodegradable. The non-aerobically biodegradable polymers doesn't count for biological oxygen demand. So mostly, as the treatment plants are designed with the help of aerobic bacteria, they are basically in activated sludge process or other processes. Actually, they are utilizing there are basically aerators. Those help in those help in increasing the dissolved oxygen content in the water. So bacteria actually utilize those oxygen to degrade the microorganism. So whatever definition Ojim has told, that is definitely correct. So BOD as basic is basically a indirect measurement of the pollutants that is present inside the water. So in this case, there is there are certain data are given. So let's see if somebody has calculated something. Okay, so Donesh has calculated is as 12 milligram per liter. Okay, oh, okay, 50. This is question option one you are telling. Okay, let's go to the question again. So it is asking about the BOD of the river water discharge point. So basically it is simple. The effluent is coming from one side and the river is coming from another side. River has got certain BOD, effluent has got certain BOD. So basically the water getting mixed. So if the flow rate is V1 and concentration is C1, so C1 plus V1, C1 V1 plus C2 V2 equals to C3 V3. Basically, this type of mass balance formula will be utilized in this case. So we'll see what is the correct answer. Actually, I also forgot. Okay. So the data given in the first case are effluent flow which is 4.32 megaliters per day. That means 4320 meter cube divided by 24 hours into 3600 seconds, that is 0.05 meter cube per second. The effluent BOD is given as 12.050 milligram per liter. River flow is given as 12 meter cube per second, and river water background BOD is given as 0. That means they are assuming there is no pollutant present in the original water of the river. So the discharge point BOD will be calculated as, so here you have to understand something. So this is the effluent flow rate and this is the effluent BOD. So if you multiply the BOD, basically the effluent concentration. So you are multiplying the effluent flow rate with the effluent BOD. So this is giving you the total amount of pollutants, the total amount of biologically degradable pollutants or pollutants expressed in terms of BOD that is present in the effluent water. And this 12 meter cube per second river flow into 0, that is the background BOD of river water, that is giving you the total pollutants in terms of BOD present in the river water. If you sum this up, this is giving you milligram per liter of pollutants that is present in the water at the discharge point after the mixing of the river water and the effluent. So this is the total amount of pollutant. If you want to calculate the concentration, then again you have to divide it with the total flow, which is nothing but 12 plus, this is the river water flow and this is the effluent that is coming in from the industry. So it will be 12.05 meter cube per second. This is the total water flow and you are dividing the total effluent, total amount of pollutant after mixing with the total flow of water. So it is 50 milligram per liter is the answer of the first question. So let's see. Okay, okay, yes. Ganesh has, secondly, you have whatever you have calculated, it is true. It is 50 milligram per liter. Yeah. Okay. So the second question asks what? Mm, the percentage BOD removal required for the industrial wastewater to ensure the BOD of the river water sustains within the permissible limit, even at discharge point at percentage. So the permissible BOD limit in the river water is given as 10 milligram per liter, and we have one value that is 50 milligram per liter. Okay, so this is the BOD at the discharge point if the water or the industrial effluent is untreated. So maximum BOD, this data is basically given. If we want to restrict the BOD at the discharge point as 10 milligram per liter, then the maximum BOD in the effluent will be 10 milligram per liter into 12.05, this is the total flow as we calculated here, into 10 milligram per liter, this is the permissible BOD. So this much amount of pollutant in terms of BOD must be there, biologically degradable pollutant or aerobically biologically degradable pollutant, this much amount must be there after the mixing. But the thing is that if you calculate it in terms of the effluent, then it comes to be, then this is basically the effluent flow rate. So you are dividing it to get the same concentration in the effluent flow. So it comes out to be 2410 milligram per liter. So how much is getting treated? So the total BOD which was there earlier, and this we have to need to maintain. So that much reduction must be there. So what is the treatment amount basically? So the treatment amount is the percentage treatment required. It is the total amount of pollutants or the effluent BOD which was there earlier, and this BOD we have to maintain in the effluent. So you are subtracting it to calculate the amount of the treated BOD or the reduced BOD which you achieved in with the help of a treatment plant, that may be an aerobic treatment plant, that may be an activated sludge process or any membrane process, by whatever means. So divided by the effluent BOD, that is 12,050 milligram per liter. So the answer is what do you calculate? 80% reduction. Yes, yes. So it is you have calculated correctly. So the answer will be 80%. So actually, in case of biological parameters, not exact value is stated. So there are basically an acceptable range is there. So in case of the BOD at the discharge point, the acceptable range is 45 to 55, and in case of the 80%, that is the percentage removal or treatment that is required, the acceptable range is 75 to 85. So if you have calculated and if your answer is within this range, then that is correct. So okay, so let's see if some more problem is there. Okay, so I think one more problem is there. So a 800 acres hectares catchment area receiving a total annual rainfall of 1400 millimeter, that generates an average daily runoff of 20,000 meter cube per day. If net annual evapotranspiration is 550 millimeter and balance water infiltrates to recharging groundwater, the sustainable groundwater withdrawal rate per day would be. That is the question. So there are options actually, I think. Yeah. So option A is 50,685 meter cube per day. Option B is 30,685 meter cube per day. Option C is 20,000, and option D is 10,685. So basically, we also calculated a similar problem in the earlier class, I believe. So 1 hectare is 10,000 square meter. It is the hint. I'll wait for 2 minutes. Time is almost over. I think please bear with me. I think this is the last problem. Yes, this is the last problem of this session. So I hope you have noted down the important data which are given in the question. So before solving this problem, we will just recall the previous class for a moment. So basically, you have to use the water balance equation in this case, and you can see that there is no change in the storage height or storage volume. No change is given, so you can assume it as 0. And precipitation value is given, I think. Surface area of the catchment is given. So this is the evapotranspiration value is also not given, I think. So you can consider it to be 0. The delta S value you can consider it to be 0. It will be simply P equals to Q out minus Q in, which is nothing but the runoff, or something infiltration term is there. So you have to, yes. So balanced water infiltrates, recharging the groundwater. Okay. So basically, there is catchment area where the precipitation is happening, certain water is overflowing, and certain water is recharging the groundwater. So there is one in and two outs, basically. And we have to calculate the sustainable groundwater withdrawal rate, that you have to calculate. Okay, so we can calculate on the basis of whatever data that is given to us. We'll see if somebody has calculated something. Okay, so I'll not make you guys wait for more, because if you have understood, I think you will be able to solve this. But it is as per all the problems which are discussed. Those are, I think, at the level of your assignment. I think if you have any difficulty in understanding or any concept gap in assignment, you can always type in the chat box or unmute yourself and talk, or you can also uh, type in the discussion forum your queries. Okay, so go with the solution. Mm, okay, so the data given is basically the catchment area, which multiplied with the, I mean, 1 hectare means 10,000, so that 800 hectares means 80 lakhs of meters square. Total annual rainfall is given as 1,400 millimeter, that is basically 1.4 meter. Total annual rainfall in terms of meter cube. Here the annual rainfall, only the height is given, so we have to multiply it with the catchment area to bring it into the volumetric term. The average daily rainfall, we're assuming average. It means though throughout the year the rain will not be there, but as the average term is there, so it is divided by 365 days. This is 30,685 meter cube per day, considering 365 days per year. Average daily runoff, I think this data is given 20,000 meter cube per day. So this amount of rainfall, average daily rainfall is occurring, and within this amount is getting overflowed or getting out of the catchment by non-infiltration means. So infiltration will be basically the daily rainfall minus daily runoff. That means infiltration in terms of groundwater and outfiltration in terms of the catchment, because the water is going out of the catchment inside the groundwater. It is recharging, basically recharging the groundwater pocket. So that will be the difference between this 30,685 and 20,000 meter cube per day. That is the runoff. This is the rainfall, this is the runoff, and the groundwater recharge rate is 10,685 meter cube per day. Now, for sustainable withdrawal, uh, the groundwater withdrawal rate cannot exceed the groundwater recharge rate, because if it withdrawal becomes exceeds the groundwater recharge rate, that will not be sustainable, because there will be shortage for utilization of groundwater for the future generations. So that's why so if maximum amount of groundwater that can be withdrawn, that is equals to the daily groundwater recharge. So basically it is also nothing but the 10,685 meter cube day, and option D is the correct answer. Okay, so evapotranspiration is Donesh is asking that why ET is not considered for calculating recharge. Yes, in practical scenario, evapotranspiration will definitely be there, but here in the problem, I mean, they have not given the evapotranspiration amount, so that's why we are considering it zero. It is actually assumption. It is a simplified problem. So if the ET value is given, then you have in the water balance equation you have to consider it. If it is not given, you can assume it to be zero.
Here, sir, evapotranspiration is given as 550.
Oh, at 220,000. Oh, sorry. I think then some problem is there. Just wait. Uh, true. Yes, actually I overlooked it. Sorry about that. Net annual evapotranspiration is given. So I think to revise the problem, I think let's see the equations. Yes, so ET terms is not zero here, basically. Okay. Uh, okay. So I think we have to consider it. Okay, I think there is a problem in this case, I think. So it is wrong. I will revise the problem actually in the next class. Today it is short. Time is short. So I think yes. So if it is there, evapotranspiration is there, then as per the equation, as per the water balance equation, you have to consider it in the equation. So I think I overlooked it. So if it is there given in the question, then you have to consider it. Okay, so sorry about that. Actually, if it is given in the question, then we have to put it in the equation. So I'll revise the problem in the next session. So sorry for identifying the, yes. So okay. Yes. So next session, ET will be actually we'll consider it in our calculations, and we will revise the solution. Okay, thank you for pointing out the mistake, Danish. Yes, actually overlooked. Okay, so thank you. We will revise the problem. Last problem, I think the rest of the sections your concept is clear. So last problem is actually, I mean, I actually overlooked while solving it. So I'll revise it, considering the evapotranspiration in the next session, uh, in the water balance equation, and we will come up with the revised solution. Okay, thank you for pointing out, Danesh. Yes. Yeah. We'll upload up to the correct portion only. Yeah. Given in lecture 15 of videos. Okay, okay, okay. Will be. Okay. Yes. Thank you for pointing out the mistake. Hmm. Okay, so goodbye. See you in the next session. Thank you. Happy Independence Day.
Thank you, sir. Good night.
Good night.